NVIDIA plus TSMC put AI in fabs, what changes for the chip supply chain? Explain why NVIDIA and TSMC moving AI into semiconductor manufacturing matters beyond one press release, how it could change yield and cycle time economics, and what operators and investors should watch across the AI supply chain next. NVIDIA just pushed AI one layer deeper into the semiconductor story. It is not only selling GPUs into AI data centers. It is now helping TSMC apply AI inside the fab itself. That matters because the fab is where chip leadership gets turned from design into reality. If AI improves speed, efficiency, and yield there, the entire AI hardware supply chain gets affected. Here is the plain English version. NVIDIA said TSMC is using AI and accelerated computing across the most expensive and time-sensitive parts of chip manufacturing. That includes computational lithography, material and transistor simulation, process control, fab scheduling, defect inspection, and digital twin planning. This is not one narrow AI pilot on a side project. It is a push into the workflows that decide how quickly advanced chips move from design to volume production. The skeptical question is fair, so what if a foundry gets a little more efficient? The answer is that small gains inside advanced manufacturing can compound across the whole AI stack. Better scheduling can reduce delays. Better inspection can improve yield. Better simulation can speed process tuning. If more usable advanced chips come out faster, hyperscalers, AI labs, and enterprise buyers all feel it. In other words, AI demand is still huge, but this is the first clear current story about AI improving the production system that feeds that demand. NVIDIA gave some very usable receipts here. It said CU litho can deliver a 20 to 50% improvement in cost effectiveness or cycle time versus CPU-based lithography. It said CUEST enables chemistry simulations that are 50 times faster on average. It said TSMC is already using H200-based scheduling for fab productivity and Vision AI for nanometer-scale defect inspection. And the broader business context matters too. NVIDIA just reported $81.6 billion in quarterly revenue, with $75.2 billion from data center. This fab story lands inside a company already riding the AI build-out at extreme scale. There are still real questions. A strong technical use case does not automatically become a fast financial win. We do not yet have public numbers showing how much these AI manufacturing workflows move TSMC margins, output, or yield at the company level. We also do not know how portable these methods are across the rest of the foundry ecosystem. So the right framing is not AI fixed semiconductor manufacturing. The right framing is that a strategic shift is now visible and source-backed. Monday morning, watch for receipts. First, any new evidence of faster cycle times in advanced node manufacturing. Second, signs that AI-based defect inspection reduces rework or improves yield. Third, whether digital twin planning tools like Fab Twin become recurring parts of fab operations instead of showcase demos. Fourth, whether NVIDIA keeps expanding from selling infrastructure into operating system-like roles around industrial workflows. If you build AI workflows yourself, this is also a reminder that the durable value often lives in the system around the model. Howard's Side Hustle Command Center is one small example of turning AI-assisted workflow design into a repeatable asset, and disclosure matters. It is Howard's ETSE product, not financial advice and not an income promise. My judgment is that this matters because AI is no longer only accelerating software and research. It is starting to optimize the industrial system that produces AI hardware itself. That does not guarantee an immediate financial step change, but it is a real strategic shift. The question I would leave you with is this: if AI starts optimizing the factories that build AI hardware, which company gains the strongest moat next, the chip designer, the foundry, or the systems layer around them? Create a polished explainer video in explainer format using classic style. Keep the narration calm, source-backed, and consequence first. Use two-host energy if supported, a lead narrator plus a skeptical analyst who keeps asking whether factory optimization is actually material enough to matter. Change the visual idea every 3 to 5 seconds using source cards, fab floor scenes, wafer inspection cards, supply chain diagrams, metric cards, and watch list checklists. Do not use fake realistic footage of specific accidents or made-up market events. Use clearly illustrative fab visuals, process diagrams, charts, and labeled conceptual scenes only. 1 May 31, 2026 to $81.6 billion quarterly revenue 3. $75.2 billion data center revenue 4. 20 to 50% lithography improvement 5. 50x faster chemistry simulations 6. NVIDIA H200 GPU 7. CU Litho 8. CU EST 9. CU ML 10. Metropolis 11. Tau Toolkit 12. Nanometer Scale Defects 13. Fab Twin 14. AI Factories 15. TSMC 1. One-page summary 2. Links mentioned 3. Key terms explained 4. Practical examples 5. Watch list and risks not financial advice. Educational analysis only. #AI #NVIDIA #TSMC